Okay, colleagues and everyone, welcome back again. This is a question that is involving Hess law. So what does Hess law say first? Hess law states that the energy in converting reactant to product is the same regardless of the route followed. So in this question, we have got this reaction. We are told use the information below to answer the question that follows. This is our equation: hydrogen plus oxygen forming water, and the enthalpy change delta H is negative 286 kilojoules per mole. We have got carbon plus oxygen forming carbon dioxide, and delta H is negative 394 kilojoules per mole. And lastly, we have got carbon plus hydrogen plus oxygen forming ethanol, and delta H, we are given negative 277 kilojoules per mole. Then we are told calculate the molar enthalpy of combustion of ethanol, given that ethanol plus oxygen forming what? Carbon dioxide and water. So the first thing we do, we will first write our equation in a cycle form. So to do that, first we write the main equation, that is carbon plus hydrogen plus oxygen, which will give us ethanol. So let's do that. So here we have got carbon plus hydrogen plus oxygen forming ethanol. So here we have got that is ethanol. So, and in that equation we have got the delta H is negative 277 kilojoules per mole. So here we write the enthalpy formation of ethanol is negative 277 kilojoules per mole. Okay, from that, we again write the energy formation of water, that is the energy, the enthalpy combustion of hydrogen, that is, and carbon. So the enthalpy combustion of hydrogen will be hydrogen plus oxygen will give us water. And the enthalpy combustion of carbon will be carbon plus oxygen will give us CO2 gas. And again, the enthalpy combustion of ethanol will be ethanol plus oxygen will give us carbon dioxide and water. So this is now our cycle. So we give now the enthalpy changes. So the enthalpy formation of combustion of carbon, here we have got negative 394 kilojoules per mole. So here we write negative 394. And the enthalpy combustion of hydrogen is negative 286 kilojoules per mole. So that is the enthalpy combustion of hydrogen, negative 286. And the enthalpy combustion of ethanol is, we are given what? That is what we are finding. So this one we don't have. Delta H. So this delta H1 is the enthalpy combustion of hydrogen. So here we write our delta H1. And enthalpy combustion of carbon, delta H2, and the enthalpy formation of ethanol, delta H3. And the enthalpy combustion of ethanol will be delta H4. So we need to balance our equation there. 2 there. Balance the oxygen. Write 3 there. And 3 there. So that is our energy cycle. So we said, Hess law says that the energy changes in converting the reactants to product is the same regardless of the route followed. So this is our reactant. So let's show you our reactant. And the product is this. So there are 2 routes that are possible. If we follow this route from carbon to carbon dioxide, from hydrogen to water, that is one route, route 1, and the other route is carbon plus hydrogen plus oxygen forming ethanol. The ethanol is again pan in oxygen to form carbon dioxide and water. So this is one route, and this is the other route. So regardless of the route followed, the energy change is still the same. So to get now the molar enthalpy combustion of ethanol, that is delta H4, we use the formula. We use this formula. We say delta H1 plus delta H2 is equal to delta H3 plus delta H4. That simply means the enthalpy combustion of hydrogen plus the enthalpy combustion of carbon will give us the enthalpy formation of ethanol plus the enthalpy combustion of ethanol. So the only one we don't have is the enthalpy combustion of ethanol. The rest we have it. So we simply now add, we take the enthalpy combustion of hydrogen plus the enthalpy combustion of carbon is equal to the enthalpy formation of ethanol plus the enthalpy combustion of ethanol. So the enthalpy combustion of hydrogen, we have got negative 286, and we multiply these 3, that is the mole ratio. So that is to say, we have got now the enthalpy combustion of hydrogen is equal to 3 times negative 286 plus the enthalpy combustion of carbon, negative 394 times 2 plus 2 times negative 394 is equal to the enthalpy formation of ethanol, that is negative 277, is equal to negative 277 plus the enthalpy combustion of ethanol, which we are finding. So to get now that one is very, very easy. So we rearrange, multiply 3 times negative 286, that is negative 858. So that is negative 858 kilojoules per mole plus 2 times negative 394 negative 88 kilojoules per mole is equal to negative 277 plus delta H4. So to get delta H4 is very easy. First, let us add these two. Negative 858 plus negative 788. That is negative 16. Negative 16. Negative 1646 is equal to negative 277 plus delta H. So to get delta H4, we simply take negative 277 on this side. So that one becomes negative 1646. If we take on this side, it will be plus 277 is equal to delta H4. So we say now negative 1646 plus 277. So that will give us negative 1369 kilojoules per mole. So, and that is the enthalpy combustion of ethanol, negative 1369 kilojoules per mole. So the enthalpy combustion of ethanol will be negative 1369 kilojoules per